Good morning, everybody. So, today we will solve this question from NCERT Chapter 7 Integrals, miscellaneous exercise. The question is evaluate the definite integral of the function cos square x divided by cos square x plus 4 sin square x dx, limits extending from 0 to pi by 2. So, it's a very simple question. Let's start. So I is equal to, I can rewrite the integral as dx upon 1 plus 4 tan square x, because I just divide it by cos square x both sides and I obtain the result. I just divide the numerator and the denominator divided by cos square x. Understood? So this I can write it as integral from 0 to pi by 2 dx upon 1 plus 2 tan x whole squared. So what dx by 1 plus 2 tan x whole squared. Now we apply the substitution. Integration by substitution method is very feasible. Substitution of 2 tan x by u is transformed into u. That implies I can write du is equal to 2 sec square x dx, and that implies du is equal to 2 into tan square x plus 1 dx. That implies du is equal to 2 into u square upon 4 plus 1 dx. That implies du is equal to u square plus 4 upon 2 dx. That implies dx is equal to 2 by u square upon 4 du. So this substitution will be used in our question. So that implies I can rewrite I as the integral from 0 to pi by 2. Now see, integral 0 to pi by 2 means, suppose this is my coordinate plane, this is a two-dimensional function. So my x coordinates range from 0 to pi by 2, and I have to find this area enclosed by the functional equation. Y is equal to cos square x by cos square x plus 4 sin square x. This is the functional graph, and I have to find, simply finding this area. Understood, everybody? So u square, so I use this substitution here. So this is, I can write 1 by 1 plus u square into dx. Dx is nothing but 2 by u square plus 4 into du. Understood? 2 by u square plus 4 into du. Understood, everybody? Okay, I am continuing. Plus I is equal to, I can take out the constant term outside of the integrand, and the limits extending from 0 to pi by 2, 1 by u square plus 1 into u square plus 4 du. Now I will use partial fraction method. Let 1 by u square plus 1 into u square plus 4 is, let it be equal to a plus u square plus 1 plus b plus u square plus 4, where a and b belong to real numbers. That implies I can write a plus b into u square plus 4a plus b is equal to 1. That implies clearly a is equal to minus b. That implies 4 into minus b plus b is equal to 1. That implies b is equal to minus 1 by 3 and a is equal to 1 by 3. So I can write that implies 1 by u square plus 1 into u square plus 4 is equal to 1 by 3u square plus 1 minus 1 by 3u square plus 4. You can simply check it. Check if any step I have committed error. Have I committed error in any step? See, you will take 3 into u square plus 1 plus u square plus 4 and u square plus 4. Yes, it's correct. It's correct. So now let's move on to next page. So that implies I can write our integral I as now 0 to pi by 2. What was our integral? This was our integral. 2 into integral from 0 to pi by 2 u square plus 1 into u square plus 4 du. So I can simply multiply 2 here and I wrote it in the form, I wrote it in the form 1 by 3 into u square plus 1 minus 1 by 3 into u square plus 4, this integrand. So I will just write it in the new simpler form, 3 into u square plus 4 du. So now this integral seems pretty simpler now, is equal to 2 by 3, the constant term is now 2 by 3, limits extending from 0 to pi by 2, 1 by u square plus 1 minus 1 by u square plus 2 square du. So that implies I can write I as 2 by 3 of tan inverse u minus 1 by 2 tan inverse u by 2 and but I have committed a grave mistake. I have to change the limits of integration. Understood? So when x is equal to 0, u is equal to 2 tan 0, which is equal to 0. When x is equal to pi by 2, u is equal to infinity. Understood? So simply change the limits of integration here. So it is infinity, it is infinity. Understood? The limits of integration will be changed corresponding to the variable you have chosen. Infinity to 0. Now I can write it as, in terms of x itself, tan inverse of 2 tan x minus half tan inverse of tan x from 0 to pi by 2. So that implies I is equal to 2 by 3 times pi by 2 minus pi by 4 minus 0 minus 0, which is equal to 2 by 3 into pi by 4